Okay, here we go with part 2. Number 13, a word problem. Uh-oh. There's no reason to panic. You know how to do these. Just be logical. With just a translate, you translate what is in the words into an algebraic equation, and then you figure it out. In this case, it looks like we're going to have a formula, but they gave us the formula. Okay, so Jeffrey drove 292 kilometers at the average rate of 73 kilometers per hour. How long did the trip take? Okay, so this we just plug in. So d equals distance, r is the rate or speed, and t is the time. So it says how long did the trip take, so we're going to be looking for t, right? How long did the trip take? That's our t. The 292 kilometers, what's that? Well, it's our distance. And this the rate, and it even tells us it's the rate of 73 kilometers per hour. So this is our rate, this is our r. So we just plug these three things into the right place. So we have 292, I guess I can even write the formula up here, d equals rt, r times t. Okay, so 292 is our distance, our rate is 73 kilometers per hour, and that's times time. Okay, the number next to the t means times, right? 73t is 73 times t. Okay, so we want to get the t alone. We'll know what the time is. We'll divide by 73. After looking at my calculator, I can see that 292 divided by 73 is 4. So 4 equals t. But what is it? Is it minutes, seconds, what? It says that, well, it was traveling at a rate of 73 kilometers per hour, so it's 4 hours. We're talking hours here. It didn't say, if it says 73 kilometers per second or something, we'd be talking about a spaceship, right? Okay, so it says hours, and it's in hours, and I'm happy. Michelle and Caitlin were betting on a lacrosse game. That's supposed to be on a... that didn't help. Okay, that's the best I can do. Michelle and Caitlin were betting on a lacrosse game. Michelle bet $40 more than Caitlin, and together they bet $200. How much did they each bet? Okay, these kind of word problems, it can be done with one variable, or it can be done with two variables. It's up to you. Now you know how to do it with two variables. I'll leave it to you. So perhaps I should do it both ways. Show you. Okay, so we're going to have Michelle and Caitlin. So Michelle, let's call Michelle X. Okay. Now in the situation where we're just going to use X, we have to devise what Caitlin is in terms of Michelle. Michelle and Caitlin were betting on a lacrosse game. Michelle bet $40 more than Caitlin. So Caitlin would be Michelle X minus 40. See, or we could do it the other way around. We could say that Caitlin was X, and Michelle then would be X plus 40, right? Because Michelle would have 40 more. So it depends on how you want to do this. So let's just do it this way for this time. Okay, so Michelle, let's make a X, and Caitlin is going to be X minus 40 because Michelle bet $40 more, right? Okay, so together they bet $200. So if we add Michelle and Caitlin together, we're going to get $200. Well, Michelle is X. Under these circumstances, we're going to have X, that's Michelle, plus Caitlin. Caitlin's X minus 40. And that, putting together what they both bet, is $200. Okay, so now this becomes a simple algebra problem. So we have 2x minus 40 equals 200. Add 40 to both sides. We have 2x equals 240. Then divide by 2, divide by 2. X equals 120. So now who's X? That's Michelle. So Michelle bet $120. Now Caitlin, she bet $40 less, right? So minus 40, 0, 4 from 12, 8. So Caitlin bet $80. And then, of course, if we add them both together, together they bet 200. Well, does 120 plus 80 equal 200? Yes, it does. All right, that's one way to do it. Okay, now let's do it the other way, the way we've been working on problems recently. We're going to make one X and one Y. So we'll make Michelle X, we'll make Caitlin Y. Okay, and they're betting on a lacrosse game. Michelle bet $40 more than Caitlin. So who bet more? Michelle. So Michelle, who is our X, equals Caitlin, which is our Y, plus $40, right? Michelle bet more. See, so we wouldn't be adding the $40 to Michelle, we were adding it to Caitlin. I know it's a little counterintuitive, but you have to see it this way. Okay, and then the other piece of information is together they bet 200. So in some ways this is easier. X plus Y equals 200. In a way, we're doing the same thing in both equations. But in the first one, we're already putting everything in terms of one variable. See, in this equation, we have to eliminate one of the variables, right, by using either substitution or elimination. Okay, so let's use substitution because we already have x equals y plus 40. So I'm going to put that in for x. So instead of x here, I'm going to put y plus 40 because they're the same thing, plus y equals 200. So this should be looking familiar to you now. See, we have 2y plus 40 equals 200. Well, in this case, we did a little bit different arrangement with Michelle and Caitlin, right? So we added to Caitlin's score to equal Michelle's. Right? So now we have this plus 40. We're going to add a negative 40 to both sides. But you notice it'll still come out the same way. So we get 2y equals 160. And then we'll divide both sides. To get to y all along, we'll divide both sides by 2. And we get y equals 80. Okay, so when we go back into look at our formula. We've got our y, we need our x. So y is Caitlin. We can put Caitlin here. Caitlin is our y, so she bet $80. And then Michelle, she bet $40 more, which we could take up here. We'll go, okay, hey, you!
Off the bus motor.
All right, that's the spirit. Okay, so that's 112. Well, you heard about our family circumstances here. All right, Michelle, 120. And again, we can add them together like this equation here, and we'll get 200. So we've checked it in both equations, really. So that problem works either way. So as usual with math problems, we have more than one way to do it. So it's your choice. However, later on, if you're asked to use substitution or elimination, you need to know how to do it that way. Number 15, solve the formula for the specified variable. All right, so we've been working equations. This is just working another equation, except that we're not going to get an answer like L equals 5 or something. We're going to get the formula. We're changing the formula around using the things we know how to do with equations to have it in terms of L. So it'll be L equals, and it'll have W's and P's in it also. So this is the variable we're solving for, L. So we want to get the L standing alone, so we'll have to add a negative 2w to both sides. Remember, we're just doing the same thing we've always done with other equations. We're working more with numbers. Here we're working with other variables. Okay, so this becomes 0. We have 2L, and on this side or we're adding negative 2w. This becomes p minus 2w. Okay, so, but we still want to get, the L all by itself, not 2L. So we'll divide by 2. 2's cancel out, and we get L equals P minus 2W divided by 2. And that's what it means by solving this formula for the specified variable. It doesn't mean getting an answer like 5 or 17 or the square root of 3. Let's do something else. Let's say we have distance equals rate times time. And we'll say we were going to solve this one for t. Solve it for t. Well, then we want to get the t alone, so we divide by r, divide by r. T, the r's cancel out, and we get t equals d over r. Let's do another one. The area of a triangle, oops, didn't mean to do that. The area of a triangle equals 1/2 the base times the height. Okay, and let's say we were going to solve this in terms of b. So we'll put 4b. So we want to get the b alone. Let's divide by h, both sides. Okay, the h's will cancel out on this side, and now we have a over h equals 1/2 b. But we don't want 1/2 b, so to get rid of the 1/2, we multiply 1/2 by its reciprocal, which is 2. And okay, so we'll put 2 in here. 2 times 1/2 b, and 2 times a over h. The 1/2 cancels out. That would be like 2 over 1, right? 1/2 cancels out, and we have b equals, and we can make that 2 over 1. We see, multiply that 2 times the a, so it would be 2a over h. Or area of a rectangle. Area equals length times width. Say we're going to do it for w. Okay, then divide by L. Divide by L. That's an easy one, right? L's cancel out. W equals the area over the length. So the idea here is we're going to still have these variables in the answer. It's just going to be in terms of a different variable. And you just do what you need to do, but you have to do it to both sides. You can't just do it to one side. Okay, here's another one. This is V equals 1/3 BH. I'm not sure what this is. Maybe it's a volume of a pyramid or a cone. Probably a pyramid. So the B is probably the area of the base. Anyway, we're going to do it for H, right? So we're going to get rid of everything else, but doing the same thing to both sides while we're doing it. So divide this side by B. This side by B. Okay, the B's cancel out. That gives us V over B equals 1/3 H. Okay, so we have to get rid of the 1/3, but we do that by multiplying it times its reciprocal. The number that you can multiply it. You can multiply some number times 1/3 to make it turn into 1. That's the reciprocal. So I'll multiply it by 3. 3 over 1. And I'll have to multiply this side. I'll do a 3 over 1 too. Okay, so the 3's cancel out, so our 1/3's gone. It's just H over there. H equals 3V over B. I know what some people are saying is that, well, can't we just divide by 1/3? Sure, we can divide by 1/3, that's fine, as long as we do it to both sides. So we start out with V equals 1/3 BH for H. Okay, so divide by B again, divide by B. So now we have V over B equals 1/3 H. Okay, let's divide both sides by 1/3. 1/3 Okay, the 1/3 cancel out and gives us h. But let's take it over here. Alright, there I have some room. Okay, so we've got v. I'm just going to do this one calculation. We've got v divided by b divided by 1/3, or v over b divided by 1/3, which equals, I'm going to write it up here, v over b divided by 1/3. And with fractions we turn over the divisor. So we have v times 3 over b. I'm going to put the 3 in front. 3v over b. You see, we ended up multiplying by the reciprocal anyway. See, but you can do it that way. So the answer, our answer is 3v over b equals h. Number 17. Use a graphing calculator to graph the following equation. Sketch the resulting graph. Okay, so if you're going to use the graphing calculator, you have to put it in the y equals form, y equals mx plus b. Or at least y equals, it actually just has to be y equals. It doesn't have to be, this is not in y equals mx plus b, obviously. This is kind of a mess, but it's in y equals. So that's what you have to have it in to put it in the calculator. And then you go to the y equals button. Okay, this is the y equals button here. You push that and you'll come to this screen with all these y's. You put in your equation right here. See, so obviously it has to be in y equals, but otherwise no big deal. That's a 2 there, but you can't see it because it's darkened by the cursor. And then you have to put a parentheses, 3.5 plus x, which x is right here. And then you have to close parentheses. Parentheses is further down on this calculator. And then you go minus, and then 9 divided by 2. And that's your equation. And then the next thing you do is you push this button here, graph. Okay, so, oops, there it is. Alright, so you push this button, graph, and this is the graph you'll get right here. Now notice, this is using the standard viewing window, which I'm going to show you right now. The standard window is, whoops. Alright, let me try again. Alright, so this is the standard window. You would go to window and you can set this all yourself. You can go negative, you put for the x min, you put -10, x max 10, x scale 1, y min -10, y max 10, and y scale 1, and ignore the other things that are on there. Okay, so that's the standard window. Another way to get to the standard window is to push on this one right here, zoom, and then you'll push 6, which and then enter, and that's the standard window. That'll reset your calculator to the standard window. An even better window would be, change this to -5, 5, 1, -5, 5, 1, and that'll give you even bigger picture. So it'll give you a better idea how to graph this. See, so the distance between, if I use a 1 scale for this and for the x-axis and the y-axis, that means that each one of these is 1. So that's 1, that's 2, that one's 3, 4, 5, and so on. And then on the x, it's 1, 2, 3, 4, 5, or -1, -2, -3, -4, -5. So when looking at this, you can see that here's -1 right here. It comes down right here and a little bit above the 2. So that's all you have to do. Is you copy then. You can just copy this line onto your scale approximately. Because copying from the graphing calculator, I know it's not going to be exact, so I'm not expecting it to be exact. If you want to be more exact, you can go to set your table, and then go to table, and you can look at the values. I would set them both for auto, and have it start oh, let's say, see, you see where this is. Have it start at like -3, and then get some of these values here, and you'll see exactly where it crosses, or very close to where it crosses the y-axis and the x-axis. But you don't have to do that. You can just copy this the way it is. So I'm going to try to do that. Well, that wasn't easy. Only because of this program I'm working with here. But so it's like near 1, and it crosses just a little bit above the 2. So that would be good enough. And that's all you have to do. Now, you don't have to do it this way. You could actually do this by hand. Do it the long ways. So I'll show you that next. Alright, to do it the long ways, it's obviously easier to do it with the graphic calculator, but to do it the long ways, you can do it. So we have a distribution here. 2 times 3.5 is 7, and 2 times x is 2x, and that's minus 9/2. So I'm going to convert 9/2 into 4.5. So this equals 7 plus 2/2 minus 4.5. Yeah, because I'm going to subtract the 4.5 from 7. And 4 from 7 is 3. 4.5 from 7 is 2.5. So we're going to have y equals 2x plus 2.5, 2.5. You can see here that if I add 2.5 plus 4.5, we get 7, right? Okay, so, whoops, didn't want to do that. Okay, m equals 2, b, m is slope, b, our y-intercept is 2.5 or 2.5. So we just need to locate these two numbers. Locate the 2.5. 2.5 is right around there. So I'd do this monster stylus. And then we count up 2.5 and then over 1. Right? Or you can change 2.5 into a fraction. Okay, so let's say we make it 2.5. 2.5 equals, turn it into an improper fraction, is 5/2. Alright, so I have to go up 5 and then over 2. So instead I'm going to make it a -5 over a -2. So I'll go down 5 and back 2. Alright, got it together again. Okay, down 5. 1, 2, 3, 4, 5, and then back 2. 1, 2, so it'll be right there. Okay, so there's our point. Down 5. 1, 2, 3, 4, 5, back 2. 1, 2. If I went down 2.5 and back 1, it's the same place. Down 2.5. 1, 2.5, back 1. It'd be right there. And notice it's right on the line. It'd be right on the line, which I'm going to put in now. Okay, so you can see from that it's the same line that we were trying to copy from the graphing calculator. This is more exact, obviously. So actually, this is much more exact. Number 18. Find any intercepts, then graph the linear equation. Okay, so we need to find the intercepts for this one to graph. We want to see if you know what the intercepts are and see how useful they are for graphing. Alright, so to remember what the intercepts are, the x-intercept is where the line crosses the x-axis. So when the line crosses the x-axis, y is 0. This is y. See, so the y value is 0. So we just stick in a 0 for y to find the x-intercept. So let's do that. Okay, 4 times 0, that eliminates the y term, so we have 2x equals 12. Divide by 2, divide by 2, x equals 6. So the x-intercept is when x equals 6. So we'll put that point in. Okay, now we'll find the y-intercept. Okay, the y-intercept, this is the x-axis, right? When x is 0, the line will cross the y-axis. This is the y-axis, right? So when x is 0, we have the y-intercept, so we'll plug in the 0 for x. You can see that 2 times 0 minus 4y equals 12. Putting the 0 in for x. The x term disappears, so we have negative 4y equals 12. Divide by negative 4, because we have to get a positive y. Divide by negative 4. 4's cancel out, and y equals a negative 3. Now notice, we're always solving equations over and over and over again. You have to get good at solving equations. If you get good at solving equations, a lot of this gets a lot easier. Alright, so now we can graph this. We have those two intercepts. We have the x-intercept, which is 6, so it's 6, 0 for the x-intercept, and the y-intercept is negative 3, so it's 0, negative 3. We'll just plot those points. I'm going to use a different color. So 6, 0 would be right here. 0, negative 3 is right here. Then we just make our line. And there we have it. Okay, number 19. Graph the linear equation, show your method. So we've learned 3 different methods for graphing equations. No doubt there are more than that. And but if you have to show your method. So the 3 we've learned how to do are the table method, the intercepts, and using the slope-intercept form, the y equals mx plus b form. So let's start out with the first lesson method we learned was making a table. Okay, so our table is right here. This will be our x, this is our y. We'll stick in values. So if we stick in, let's say we put in a negative 1 for x to start off with. So then we have to solve each one of these. This is why this is usually the harder method. 4 times a negative 1 minus y equals 1. So this becomes 4 minus y equals 1. Let's add a positive y, and that gives us 4 equals y plus 1. Okay, add a negative 1, and that gives us 0 here plus y equals 3. So our first one is 3. Now let's pick 0. 0 for x. So we've got a negative 4 times 0 minus y equals 1. Negative 4 times 0 is 0, so we have a negative y equals 1. And we'll multiply through by a negative 1. Negative 1, negative 1. And we get y equals a negative 1. Negative 1. Now let's try 1. Negative 4 times 1 minus y equals 1. This becomes a negative 4 minus y equals 1. Okay, add 4 to both sides. Notice I'm always doing it the same way. I'm adding, I either add or subtract or multiply or divide the same thing to both sides, right? So we have a negative y equals 5. And we have to multiply both sides by negative 1. Negative 1. And we get y equals negative 5. Okay, so let's plot our points. Negative 1, 3, right there. 0, negative 1. Okay, and 1, negative 5. Uh-oh, I did something wrong. Can you tell why? Okay, so negative 1, 3 is right. 0, 0, negative 1 is wrong. Okay. 0, negative 1. There we go. See, I can make a mistake. Okay, 0, negative 1. And then 1, negative 5. See, all three, that's when you're using a table, doing a table, that's why you want 3 points, so you can see if you've got something wrong, if you've done something wrong. Okay, so now we can graph our line. The next method we learned was finding the intercepts, so we'll do that. We'll stick in 0 for x. Okay, so negative y equals 1, so y equals a negative 1. Okay, so there the y-intercept is negative 1. We already have that right there. Okay, and now we'll stick in 0 for y. So we have a negative 4x minus 0 equals 1, sticking in the 0 for y. So we get a negative 4x equals 1, divide by negative 4, divide by negative 4. So that cancels out, and we get x equals a negative 1/4. So now that's not as great a spot, right? Have your intercept. So we do, you can see our line already crosses that spot, which of course it should. So the x-intercept is right there. Okay. But usually that's not so great. So we wouldn't use the intercepts in that circumstance because we'd rather have them cross where these lines cross, you know. The last method we learned, well actually it wasn't the last method, but the last method by hand we learned was using the slope-intercept form. The slope-intercept form, as you know, is y equals mx plus b, where the m is the slope and the b is the y-intercept. And that's the easiest way to graph. So sometimes finding the intercepts is easier than finding the slope-intercept form, but usually finding the slope-intercept form is the easiest way. All right, let's do that. So to do that, we have to get y alone. So we'll add 4x, add 4x. This is the same as like putting a formula in terms of one of the variables. That's all we're doing here is we're putting this formula, the y equals mx plus b, in terms of the y. So We add that and we get a negative y equals 4x plus 1. But now we have a negative y. We want positive y. So we'll multiply through by negative 1. And we get a positive y equals a negative 4x minus 1. Okay, so our slope is a negative 4. M equals a negative 4. And our y-intercept, our b, is a negative 1. So we find the y-intercept first. The y-intercept is negative 1. We've already covered that one twice. That's right there. Okay, so now we count our slope. We have to make a fraction out of the slope. So negative 4 is the same as negative 4 over 1, or 4 over a negative 1. We use the one that works easiest for us. So we'll count our slope from here, and we'll go, let's say we'll go down 4. 1, 2, 3, 4, and over 1. Notice we already have a dot there. Okay, and we could count it the other way too. We could count it using this one, 4 over negative 1. Up 1, 2, 3, 4, and then back 1. And notice we have a point there already too. Okay, so that's our third way of doing it by hand. The other way is to do it on the calculator. On the calculator, you graph it into the y equals. You put it in the slope-intercept form in the y equals. So that you put negative 4x minus 1 in there, and then you could either push graph, and then you'll see the graph, but it's not as exact. It's harder to see it. So what you might want to do is, just to get the points, go into table set, which is TBLSET, and to do that, when you push second window, and you'll notice table set is right above that in blue. So you push second window and you get the table set, and you set the table to start at, let's say, negative 1. Start at negative 1, and then have it go up in increments of 1. So the change will be 1, and then put both of the things for y and x, I forget what they're called, put them both into auto. And then when you push table, which is graph, second graph, table's right above graph, you'll get a table, and you get all the values you want. You can just plug in those values. Okay, so here we go again. Graph the equation number 20. Graph the equation, show your method. Notice it's already in the slope-intercept form. So hey, why not use that? And that's what I'm going to do. I would recommend that you try it a few different ways. Try it with the intercepts, try it with the slope-intercept form, try it with the calculator, try it with the table, just to get comfortable with all four methods, so that you can choose the one you want when you need to, and you'll also be quicker at it. You know, you won't have all this hesitancy, wondering, oh, do I know what I'm doing? Okay, so it's already set up for us. B is 5. We'll do that first, and then our slope is a negative 3/2. So where is 5? It's right here. That's a rather big dot, right? Okay, so negative 3/2, so that's helpful because we can just go down 3, 1, 2, 3, and we'll stay on our graph. Go over 2, it's right there. And then we draw our line. And there's our line. Number 21, graph the equation. Again, another equation to graph. Now this one is y equals 5. So these equations that are like y equals 5 or equals 6 or negative 7, or x equals 0, x equals 10. They don't look like lines in that the equation doesn't have the other term in it. It doesn't have the x or y term in it. But if you think about this, the standard form is ax plus by equals c, where the c, the b, and the a are just numbers, constants. And so if we put it in that form, we have y equals 5. Y equals 5. The constant for y would be 1. The c here is 5. And if we added an x term, the constant for x would be 0. See? So no matter what x was, it would be just the value of y. So here, y equals 5 is where y is always 5. And where is y always 5? Well, first thing to do is like plot the intercept and then draw the line right where y is 5. That is y equals 5. If we were doing a different one, if we were doing like x equals 3, well, where is x always 3? Well, the full equation would be 1x, that's our a, plus 0y equals 3, right? So the y term always gets canceled out by the 0. So x, the value of x is always 3. And where that is right here. 1, 2, 3. Right here. That's x's. X equals 3. So don't get confused by, see, it's a little counterintuitive because when it's y equals something, it's a horizontal line. But you see, that is where y is always the same value. And again, where it's x equals, it's always a vertical line. So the answer to this, y equals 5, is this line right here, where y is always 5. Number 22. Use the equations below to answer the questions. Which two of the following equations represent parallel lines? Which two represent perpendicular lines? So you have to remember what parallel and perpendicular mean in the first place. So I'm going to show you what parallel lines are. Okay, these are parallel lines. They're kind of like train tracks. They'll never cross. They'll never cross each other. So they all have the same slope. They're all angled in the same direction. If you figure out the slope of any of these, you'll find that they're all exactly the same slope. And one way to remember what parallel is in the word parallel, there are two L's next to each other. They're like parallel lines. Perpendicular is like this. It's like where the wall meets the floor. It's a right angle, 90-degree angle between the perpendicular line and the line it's perpendicular to. So the question is, how can you tell when lines are going to be parallel or perpendicular from their formulas? So we can look at these formulas. You don't even have to graph them. If you have to put them into the y equals format. Y equals mx plus b, where b is the intercept, but the important thing is the m here. In this case, that's our slope. That tells us what our slope is. So we can compare these four lines now. If we're let's first look for the parallel lines. Parallel lines are like these two. Here we go. This one and this one. These two are parallel. They never cross each other. They have the same slope, the same incline. And both of these are positive slopes. So now let's look at each of our slopes. See, here's a slope, here's a slope, there's a slope, there's a slope. That's the m part of y equals mx plus b. So which ones are the same? That's all it is. So -4 and 4 are not the same. -4 and -4. Those two are the same. So these two, this one and this one, they are parallel to each other. As a matter of fact, if you wanted to, we could graph them. We would see that the intercept of this one is a -1, which would be right there, and the intercept of the other is 0. It would be right there. But you count the slopes both the same way. They're both -4, so they would be down 4, 1, 2, 3, 4, and over 1. Both of them you count down 4 and over 1 from their intercepts, and you'd find you'd have the same exact slope for each of them. When you draw the lines, both lines would be parallel. Okay, so now which one is the perpendicular line? Okay, perpendicular line. Which of these are perpendicular? Well, they're not going to have the same slope, so it's not going to be this one and this one. These won't be the pair that are perpendicular to each other. Notice these two lines, this one and this one. You notice there's one thing that's different about them is they have the opposite sign. This one is a negative slope, it's going downhill from left to right, and this one's going uphill from left to right. So perpendicular lines are going to have the opposite sign. So which ones have the opposite sign? Well, the -4 and the 4 have opposite signs. Also, the 4. No, those are the only -4 and 4, and the -4 and the 1/4. They have opposite signs. 1/4 and 4 are positive. Okay, so it's got to be one of those two pairs. It's got to be one of these -4s paired up with one of these guys. But which one? So we could actually graph one of these lines and find out. All right, so I've just graphed one. This one is this line here. See, -1 is the intercept. That's where I put the point. And then the slope, you count the slope, it's a -4, which equals a slope of -4 is the same as -4 over 1, right? So we'll go down 4, 1, 2, 3, 4 over 1 to here. Okay, so that's the -4 slope. So the one that's perpendicular to it is going to have the opposite slope. So let's try this one first. We'll graph that line and we'll see if it's perpendicular to it. -5 is the intercept right there, and then let's count the slope from that point. Okay, so that slope is a +4, or 4 over 1, so we go up 4, 1, 2, 3, 4, but over 1 to here. Okay, so that's the point right there. So look at this new line. That's not perpendicular. It doesn't form like a T. You know, a T is perpendicular. You know, that's perpendicular. Or if we were going to do it with these lines, same angle these lines are. You know, perpendicular has got to become something like that. Or which one line was it? Yes, that was the line. It's got to be more on this. It's got to be more on this angle. So that is not the one that's perpendicular. All right, the last one to try then would be this one here. Okay, to see if that's perpendicular. So the intercept you can see is 2 right there, and the slope is 1/4. So we go up 1 and over 4. 1, 2, 3, 4, right to there. When I put a line and put that red line through those 2 points, you can see now that these 2 lines, where they cross, you see how they cross? They are perpendicular. So what's that relationship then in numbers, you know? So our first line was this one. Our line that's perpendicular to it is this one. So compare them. One is -4 and the other is 1/4. So they have opposite signs, and what's 1/4 to 4? It's its reciprocal. It's its reciprocal. You notice if we count the slope, from our first line, which the point was, starting at -1 here, we go up 4, 1, 2, 3, 4, and back 1. Or, well, the line isn't exact, but we go down 4, 1, 2, 3, 4, and over 1. This one, our new line, this red line, we go up 1 and back 4 and over 4. 1, 1, 2, 3, 4. See, so it's kind of the opposite in two different ways. In one way, it's reciprocal. It has the same numbers in the slope, except that they're switched. One of them we go up 4 and back 1. The other one we go up 1 and over 4. So they're not exactly the opposite, but one's the negative reciprocal of the other. So you just have to remember that. They're very similar. And actually, you would actually count the same slope if you did it sideways. If you counted the slope from here going sideways, going this way, as if the whole graph was turned sideways on you, you notice that it goes 1, 2, 3, 4, and then back 1, just like the slope from here, counting from this point, 1, 2, 3, 4, and back 1. So if you turn the whole thing sideways, you can actually count the same slope for a perpendicular one. So the perpendicular slope is opposite reciprocal. And that's probably all you want to hear about that, right? Now, that number 22, that was exhausting for me. So let's see how this one will be. Number 23. Find the equation of the line with the slope and y-intercept given in the graph below. Okay, so this is actually quite easy. And we can find an equation of the line if we have the line and we can count it. The nice thing about this line is it crosses these interstices, where the grid crosses it here, crosses it here, crosses it there, 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 and there. So we could pick any 2 points, but we might as well pick a couple that are close, right? So we'll start here. You have to find the y-intercept though. Yeah, one of the points has to be the y-intercept. Right, so we have to -4. We can judge the slope from any 2 points where they cross, but there's only one y-intercept with a line, so the y-intercept is -4. M equals -4. Okay, so let's just count our slope. We'll go up 2, 1, 2, and over 1. So B equals rise of 2, run of 1, or equals 2. Okay, so if we have this slope-intercept form, y equals mx plus b, we'll just plug in the numbers we found. Slope of -4, -4x plus 2. Y equals -4x plus 2. Pretty easy, don't you think? Number 24 says, use the graph to solve the problem. Find the rate of change in Carlos's weight. Okay, so we have to do a couple things here. One of them is we have to read the graph. We have to know what these things mean. Okay, so our y-axis goes from 144. You notice the squiggly line here, so it doesn't start at 0. It starts at 144, and then it goes up to 172. And the y-axis is telling us weight in pounds. So it's pounds. These are all pounds. That's the first thing you do, is you got to figure out what it is it's talking about. And then down here, months since the start of diet. It doesn't say when he started the diet, just months. So this is 1 month after he started, 2 months after he started, 3 months after he started, 4 months, so on. And you notice that the data, they plotted the points. He took data for 5 different times. And of those 5 different times, they're all in a straight line. So you can draw a straight line, so you can make an equation out of that if you wanted to and predict what his weight loss would be for say 6 months after the start of the diet. or even 7 months after the start of the diet. You'd have to expand the graph though. Okay, the other thing is, it says find the rate of change in Carlos's weight. The rate of change. The rate of change is the slope. This is Carlos's weight. These are the months going by. The rate of change will then be in months or pounds, pounds per month. Pounds per month. And so the way we find the slope is we have to pick points that are strategic for us. Notice these points, this would be one grid line here, right? And then this is another one. This point is right on where the grid lines cross. We can see it's exactly 172 pounds and exactly at 1 month. This one is in the middle, and it's hard to predict what that is, or hard to estimate what that is. This one is right on the place where they cross too. So this would be a good point too. See, this is at 3 months and at 160 pounds. And then this would not be, because it's in the middle. It's hard to tell. I mean, that may work out, that may be 154, but it may not be, it may be 153.8, But this one is right on the nose, right at where 5 months crosses with 148. So we can use those 3 points, that one, and that one. We can use those with some degree of comfort. Now we have to keep in mind that we're looking for a slope, and we have points, so we'll use this formula. Slope equals y2 minus y1 over x2 minus x1. So we have to have some points, so we'll write the points in. This first point is our x. We put our x term first. It's 172. 172 is our y, the 1 is our x. The next one, see if you can guess these before I mention them, or not guess, but figure them out. 3, 160, and then the last one is 5, 148. Okay, so then we just have to pick 2 of the points and plug them into our formula. And what I recommend doing is making one first point. So let's make this one number 1, and I'm going to make this one number 2. But you can pick any 2 points, and you can make any of them number 1 and any of them number 2. You just can't make the same point number 1 and number 2, right? Okay, so if this is our point number 1, this is x1, this is y1, and this is point number 2. We'll make that x2, and this is y2. See, so now doing that allows us to just plug in the information into our formula. So where am I going to do this? I guess over here. So for y2 is 148. So we have 148 minus our y1, which is 172. And that's over x2, 5, minus x1, which is 1. Okay, so we make these subtractions. I'm going to put the answer down below it. Okay, 148 plus a negative 172, or minus 172, is a negative 24. You have to keep track of the signs. If there's a negative sign, you got to use it. Okay, and then in the bottom, 5 minus 1 is 4. So 124, negative 124 divided by 4 is a negative 6. Okay, so a negative 6 what? A negative 6 what? Well, we're talking about pounds per month, right? So it's a negative 6 pounds per month. And so why negative? Well, notice that the slope of our graph is a negative slope. And also, well, that's the negative number we got. His weight is going down. It's going down by 6 pounds every month. So that's why it's a negative 6 pounds. So we usually say, oh, a person, he lost 6 pounds a month. And that's using the absolute value of 6. So that's because we usually talk that way. We talk that way about debt. We talk that way about below sea level, above sea level, and so on. Below 0 in temperature. So, and losing yardage or gaining yardage in football, we usually don't say negative yardage, right? So here we say his rate of change was a negative 6 pounds a month. Okay. Okay, so much for part 2. Now move on to part 3, starting with problem number 25. I hope.